Okay then, we will do training YOLO v7 on custom objects. Make sure the dataset is set up and the configuration file is created. Before doing training, we have to download pre-trained weights for transfer learning. Visit the following repositories. Scroll down after that. Download YOLO v7 training from the transfer learning section. Click on the following link. Wait until the download is finished. When you're finished, navigate to the weights file in the downloads folder. After that, move the weights to the YOLO v7 GPU's root folder. Click the file, then press Ctrl X. Paste in the YOLO v7 GPU's root folder by pressing Ctrl V. But before doing the training, we will explain some arguments that can be used. First, there is the workers argument. This argument is the number of processes that generate batches in parallel. This is an example of its application. Next is the batch size argument. This argument is the number of images processed before updating the model. This is an example of its application. If the GPU used for training has relatively small RAM, set workers to 0 and reduce the batch size. Next is the device argument. This argument is queue the device. This is an example of its application. If using CPU, write CPU and device. Next is the data argument. This argument is a data file that contains the number of classes, dataset path, and class name. This is an example of its application. Next up is the img argument. This argument is the size of the image to be trained. This is an example of its application. Next is the cfg argument. This argument is a configuration file. This is an example of its application. Next, weights argument. This argument is a weights file that is used as pre-trained weights for transfer learning. This is an example of its application. Next, name argument. This argument is the name of the model to be trained. This is an example of its application. Next, hype argument. This argument is a YOLO v7's hyperparameter. This is an example of its application. Next is the epochs argument. This argument is the number of times the learning algorithm will work to process the entire dataset. This is an example of its application. The first step in performing the training is to launch the Anaconda prompt. Press the Windows button, then enter Anaconda. Click the Anaconda prompt. Then activate the YOLO v7 GPU environment using the command activate YOLO v7 GPU env. Press enter. Then navigate to the YOLO v7 GPU's root folder. We will do training with the face mask dataset. The NVIDIA GeForce GTX 1650 Ti with 4 GB of GPU RAM is used for training. Use the command below. Python train.py. In workers, set 0. In the batch size, we write 4. You can increase the batch size value if you're using a GPU with more RAM. On device, 0. In the data, write the data file that was previously created. At img, we write 640. In the cfg, write the configuration file that was previously created. In weights, we use YOLO v7 training as initial weights. In the name, we write YOLO v7 face mask. In head, use head-scratch custom file in the data folder. In epochs, we write 300. Press enter to start training. The following is the training process. Each epoch will calculate the MOP to get the best weights. If you want to stop training before the specified epochs, you can press Ctrl+C. To view the training results, launch Windows Explorer and navigate to the YOLO v7 GPU's root folder. The training results are stored in the runs, train, model name. The training result weights file is stored in the weights folder. Dash.pt is the weights with the highest MOP value. Last.pt is the weights of the last epoch. Next, we can see the training graph using the Tensorboard. Use the command below, Tensorboard --logdir. Runs train. Press enter. Copy the following link by blocking like this. Then right-click. Open your browser. Paste the copied link. The following is a graph of the training results. For performance, you can pay attention to the MOP graph or mean average precision. The higher the better. In the next video, we will explain how to continue training. See you then.